Okay, so let's go ahead and get started with the questions. 23. 23. Okay, so let's do 23. We have 1 minus cosine t over 2 squared sine t over 2 dt. And it actually tells you, gives you the substitution. U is equal to 1 minus cosine t over 2. Okay, so where do we get stuck here?
I was just confused on the part when you've done all of the like replacing,
Uh-huh.
but then when you differentiate it, I was
Uh-huh.
just confused on how they got to where they were at.
Okay, so we get the 1/2 in front, right? Did you do the 1/2 in front, the chain rule?
Yeah.
Okay, so I'm gonna go u squared, and I'm gonna move the 2 over here, right? Like this. So this guy here now becomes this. So we're gonna do 2 du's. Did you get this far?
Yeah.
Okay, so this is going to be equal to 1 over 3u cubed plus c, and there's a 2 here, right? So the 2, right? Are we good here?
What did you do?
I'm going to pull the 2 out here,
Uh-huh.
move in front.
Yeah.
So this is this. Do we get this?
Oh, okay. Yeah.
We good
Sorry,
here?
I was just confused. Yeah.
2/3 1 minus cosine t over 2 cubed plus c. That would be your answer.
Okay, yeah. Thank you. I just got confused in
Okay.
that middle part section. Thank you.
So we're good with that one. 27. 27. We have square root of tan x secant squared x dx. So what did you do here, Christina?
I couldn't figure out like how to put u.
So u is equal to tan x.
Okay.
And that allows us to do du, and I get secant squared x dx. So I created this guy here. This guy's going to be equal to du. So I'm going to get square root of u du. Are we good?
Yeah. Thank you.
We good? So this is just u 1.5, and you just do the integral, and you just, so you get what, 3 over 2 u 3 over 2 plus c. So it's going to be 2, 3 tan x 3 over 2 plus c, and that's it. Okay? So that's 27. 29. 29, we have dx, right? So we're going to just, you want to say u is equal to 4x plus 2. Du is equal to 4 dx. So if I divide by 4, this is what I get. So this is going to be equal to tan u du over 4. So it's 1/4 tan u du. Are we good? Christina?
Oh yeah. Yeah, I got till that part.
You got to this
Like-
part?
Yeah.
Okay, so this is going to be what? Whoops, the other way around. Sine u cosine. So this becomes what? 1/4 natural log of what? Cosine u, which basically becomes, now I can go ahead and put the 4x plus 2 back in. Right? Did you get stuck here?
Oh yeah, I got stuck there.
Okay, you understand what we did here, right?
Mm-hmm.
We've done this before. We've done this in, where was that? We did this in similar to example number 6. Actually, if you go to page 341, does it have that here? No, it doesn't. Let's go to page, where's the useful formulas? Page 601. On page 601, it tells you how to do the tangent. I hope somewhere here. 602, number 32. Okay?
Yeah, I see that. Thank you.
All right. Okay, and then we have 60. Okay, number 60, 60. Where are we at? Okay, so I have 0 to pi over 6, cosine -3 2 theta, sine 2 theta, like that. So did you, what substitution did you try to use there, Lauren?
Well, I just tried to take that I did t and I did t is equal to cosine 2 theta.
Okay, so u is equal to cosine 2 theta.
Mm-hmm.
Du is going to be equal to -2 sine 2
Sine
theta d theta.
Mm-hmm.
We're good? So you're going to
Yeah.
divide this by -2, right?
Yeah.
So this guy here now becomes this, right?
Yeah.
So you're going to go u -3 du. And then you're going to have a -1/2 here, right in front. Right? The -2
Yeah.
right here.
Mm-hmm.
That's right there. Now I have to go and go from 0, so I have to put when theta is equal to 0, I get what?
In this equation, or
No, where it's a definite integral, right? So I have to change the limits.
oh, okay. Oh, so you plug the limits in. That's why I was getting confused
Okay, so
at
you get 1, right? And over here,
Mhm.
you would put this
pi
is-
over 6 in for theta.
Yeah. Okay.
Okay.
Got it?
Yeah.
You good?
Yeah.
All right. Yeah, so that's the part that I said. Remember, when you do the definite integral here, that you always have to change it back into your whatever you did the substitution to. Okay. All right. So that's that. We're good. All right. So let's move on to 7.3. 7.3. We're going to do anti-differentiations by parts. This is kind of the same mindset or philosophy that you had with the substitutions, okay? You have to be very deliberate, okay? Again, you don't want to try to do 2 or 3 different steps at a time, okay? So product rule and integral form. So what we're going to do is we're going to say that the anti-differentiation by parts starts from this, okay? UV, the product rule. When I take the differentiation of this, I get U prime V plus UV prime, correct? I'm going to go ahead and take the derivative. Now I'm going to take the integral of everything. Okay, so what does this become? So basically what I have here is I'm going to have U prime V. If I solve for this guy, I can just move this guy over, right? So it's going to be UV prime minus UV prime as such, right? What happens to this? Does this basically become UV? Right? Because I took the derivative and then I took the integration back again. Okay, so this is really the differentiation by parts right here. This is where it comes from. So if you go to page 349 in the middle, it shows you that, right? The integral of U prime V. So UV, so they got it backwards here. So they did this, which is the same thing really, like this. So UV prime, which is dV, right? Then I have, this is UV minus U, the integral of U prime V, okay? So basically you have to set, so you have to look at what you're trying to take the anti-differentiation of as being the product of two different functions, and you're gonna do this, you're gonna use this, okay? So this looks a little bit confusing, so let's go ahead and just do one of the examples. Let's jump right into the example, okay? So example number 1, I have x cosine x dx, okay? So again, I'm going to set this as being what? One is going to be u, the other one's going to be v prime, right? So I'm going to say u is equal to x, and v prime is going to be equal to cosine x, okay? Then u prime would be what? If I put u is equal to x, u prime would be what? Would it be 1? Right, because I take the differentiation with respect to x here, right? So over here, I'm getting v is going to be equal to what? Sine x, right? V is going to be equal to sine x. Because when I take the differentiation of this, I get that. Okay, so I said that this was going to be u. Let's go ahead and do this in a different color so I don't get too complicated here. So this is going to be u. This here was v prime, okay? So when I take the differentiation, so when I do the integration, I'm going to get uv, right? uv, u times v, minus u prime, which was 1, times v, right? So this one basically becomes like that. And now I'm going to get what? X sine x. What do I get here? I get cosine x plus c. Okay? Well, it's just positive, right? So I get, when I take the negative, when I take the derivative of this, I'm going to get negative sine x, right? So are you good there? So let's go ahead and see if this actually worked, okay? So let's say this actually, so if I take the derivative of this, I should get this guy right here, right? If I take the derivative of this, what do I get? I get 1 times sine x plus x, the derivative of this, which would be cosine x. And I take the derivative of this, I'm going to get negative sine x, the c goes away, this goes away, and indeed, this is what I get. Okay, so what could have gone wrong here? So the worst that could have happened is that if I take this the wrong way, right? If I go ahead and take u as this guy, if I call this guy u, and this guy v prime, okay, if I did that, I would end up, it would not work. So it's a 50-50, 90 type of thing, right? So you can try it one way, if it doesn't work, you just do it the other way. Okay, all right. Are we good so far? All right, let's move on. Let's move on to the next one. Example number 2 on page 350, differentiation of x squared e to the x dx. Okay, so if I take u as being x squared, v prime as e to the x, what would u prime be here? Luke, what is u prime?
Uh, 2x.
2x, good. What would my v be here? What would I take the derivative? What when I take the derivative gives me this? It's just e to the x, right? Just e to the x, right? So this is going to be equal to uv. I mean, where am I at? So it'd be uv, which is x squared e to the x minus the derivative of this guy, right? So it's going to be 2x e to the x dx. Okay, well, this is not something we know how to do, but what did we accomplish? We went from here, where it's x squared e to the x, to now, if I pull the 2 out, I get x to the ex. So I actually made it down to, now it's only x to the ex, right? So I'm going to do it again. I'm going to do it one more time. X squared e to the x. Now let's go ahead and do this. Do the same thing. U is equal to x, which means that u prime is going to be equal to 1. V prime would be equal to e to the x, where v would be equal to e to the x, right? So this guy here is going to be minus 2. Now let's go ahead and look at this guy right here, right? So I get uv, which is going to be x e to the x, minus this guy here, right? Which is e to the x dx. Okay? So now I know how to do this. I'm good with this. Now these are all done. So I get x squared e to the x minus 2 times x e to the x. Minus minus cancels out. I get plus 2 e to the x plus c. Okay? All right. I know this is kind of hard right now, hard to wrap around, but as you do your homework, you will get better at this. Okay, now as you see, I went from here, I went to here. So I reduced the x squared ex to the x e to the x. And I did it one more time, and I got now just e to the x, which is something I can do. Okay? All right? Again, it's not easy, all right? You just have to just keep on doing, just keep on going with it. Okay, let's do example number 3. Example number 3 is basically the same thing, but now they're going to throw in an initial value. Okay, so solve a differential equation that x to the ex, so I have the y prime is going to be equal to x natural log of x. Okay, which means that what? If I take the derivative, I'm trying to find y, which is basically the derivative of This is what I'm trying to find, right? But I'm given an initial condition that when x equal to 1, y is equal to -1. I'm given this. Okay? So let's go ahead and work this. I go here, I'm going to go u is going to be equal to what? If I put u is equal to natural log of x, what is u prime? Natalie? Natalie? Are you there, Natalie? Natalie's not here. Where is Natalie? Caden, what is u prime? If u is equal to natural log of x, it's just a derivative of u. What is it? Christina?
Um, 1 over x.
1 over x, right? 1 over x, good. Okay, so v prime is going to be x, so v is going to be equal to what? What, when I take the derivative, do I get x?
1.
1/2 x squared, right? So if I take the derivatives, I get this, right? So let's go ahead and, so I'm going to get one over here. I'm going to uv, which is this guy, x squared over 2 times natural log of x minus this guy here, which is going to be x times 1 over x d of x. What does this guy become? This guy becomes 1. So basically I get what? X squared over 2 natural log x minus, I'm going to get x plus c here, right? But now that I have this condition, I can actually solve for c, right? Because when x is equal to 1, this is -1. So I get -1 is equal to 1 natural log of 1 minus 1 plus c. What is a natural log of 1, Kayla?
Zero.
0. So this guy goes to 0, -1, -1. So c is going to be equal to 0. So I know that c is equal to 0. So my answer is going to be this guy right here. Okay? Seems as though this is not correct. I did something wrong. What did I do wrong here?
I think it's the x, the minus x in the equation.
Oh, what? Well, it's this guy right here, right? This guy, I have to multiply this guy and this guy, right? So this guy is not right. So it's going to be, answer one. This is going to be 1/2 of x squared. X squared right there. So this becomes what? 1/2 of just x, right? X, so it's going to be 1/2 of, so x is going to be squared 1/2. Okay, so this is where I was, plus c. All right, now let's go ahead and put this back in. So I'm going to get -1 is equal to x squared over 2, natural log of 1. Oh, this is 1 actually, 1 squared minus 1/4 plus c. This goes to 0. I move the quarter over there. I get c is equal to -3/4. So this becomes -3/4. Okay? I understand where I got this wrong. I should have multiplied these two together, right? Not these two together. It had to be this guy right here, right? Okay, so that's how that works. Okay. Let's do one more. And then I'll let you get started on the homework after this guy. This guy is going to be a little complicated, but let's go ahead and just work it through. Example number 4. I am trying to find e to the x cosine x dx. Okay, so here I'm going to put what? U prime, or U prime is going to be equal to e to the x. V is going to be equal to cosine x. What is V prime going to be then? Anybody? Negative sine x, right? U is going to be equal to e to the x. So this is going to be equal to e to the x times well, what am I doing here? So this is e to the x cosine x, right? This guy right here, right? Then I'm going to multiply it by this guy right here. So it's going to be negative, but I have a negative here, so the negatives cancel it out. I get e to the x sine x dx. Okay, so this is kind of confusing. I went from e to the x cosine x to e to the x sine x. Is this an improvement? Does this look better or not?
It looks the same.
It looks the same, right? It looks like we didn't make any really, wait a minute. So this is, what am I doing? This is u prime, this is v. So I get u, which is this guy, times v, right? And then over here, I get u times v prime minus, okay, we're good. Okay, so let's try this one more time and see what happens. Okay, so I'm going to go and do this now. So here again, I'm going to go u is equal to e to the x. U prime is going to be e to the x. V prime is going to be equal to sine x, which means that v is going to be equal to what? Negative cosine x. So I'm going to get this is going to be equal to e to the x sine x minus, well, I'm going to get e to the x cosine x dx. There's a negative there, so it becomes positive. I'm going to end it with this. Oh, this is negative. I'm sorry, negative. Okay, so what happened here? What ended up happening?
Went in a circle. We're back at the
I went
beginning.
into a circle, right? I came up with what I started with. Is this good?
Unless you like circles.
Ah, okay. So here's where you got to, this is really going to be really interesting. So if I call this x, if I call this large x, what do I have? I have x is equal to this plus this. What is this?
X?
This is x also. This is good, because now I move the x over, I get 2x is equal to this. Correct? There's a c here, obviously, right? So x, which is what I'm trying to find, is going to be equal to e to the x sine x. I'm going to put this, write this one first. Cosine x divided by 2. So I actually did end up solving it. You see that? So this is where you kind of get to blow your mind here. It looks like we were going in circles, right? But in the end, this is where we got. We actually solved the equation. Does that make sense now?
How long do you think it took people to figure that out?
I don't know, some brilliant minds have figured this out, right? Okay. But you see, even though it looked as though we were going through circles, going in circles, we ended up coming back, finding we actually found what we had set out to find. Okay? All right. So we'll stop right here. We'll call it good for the first half.